Hello and welcome to the final video in our Year 9 Indices series. Today we'll be talking about significant figures, how they're used, and what exactly their purpose is. So let's dive straight into it. Usage of significant figures. So we've talked about scientific notation in our last video. So if you haven't seen that, go check that out. But we might write specific numbers, something like 8.32 times 10 to the negative 4. Now, what does this number actually represent? Well, it represents 0.000832, right? And it's quite tedious writing all those numbers out. Instead, we just opt out for the simpler way of representing it. Now, this example indicates three significant figures. Now, scientists often round measurements to lesser significant figures due to uncertainty. And now this uncertainty is normally due to precision of our measuring instruments or just like the numbers we've been given at the start of an equation. Now, before we even jump into this example over here, I want to give one example which sort of covers all the things you do need to know. So I'm going to give you an example of 0.0053020. So we can classify all the numbers here into four separate categories. We have what we call our non-zero numbers. We have what we call our leading zeros. Okay, so these are all the numbers, all the zeros, sorry, leading zeros, all the zeros that occur before our first non-zero number. Then we have our in-between zeros. So as the name suggests, these are the zeros in between our first and last non-zero number. Remember, this is our first non-zero number. This is our last non-zero number. All the zeros after our last non-zero number is what we call trailing zeros. And I think trailing is a fitting word, a fitting description for what these zeros are. They're trailing. So we can see how many numbers do we actually have here? We have 1, 2, 3, 4, 5, 6, 7, 8, 9. How many of these are actually significant? Well, the answer to that question is 6. 6 of them are significant. What do we classify as significant? Significant figures include non-zeros, so non-zero numbers, our in-between zero numbers, so our in-betweens, and our trailing, okay? So these are all classified as significant. And that is why this portion of our number is classified as a significant portion. So now that I've sort of gone through that example, just keep all of that in mind so that we can have a go at these four questions in regards to this. Okay, so question one. How many significant figures are in this measurement over here? Now remember, do we have any zeros here? We don't actually, right? This is just scientific notation. We really only care about this. There are no zeros here. So that means they're all non-zero numbers, which means they're all significant. So 1, 2, 3, 4, 5, 6, 7, 8. We have 8 significant figures. I can abbreviate that as 8 sig figs. I can even write 8 SF. Doesn't really matter. So 8 significant figures. Now, question 2. Write the mass to 5 significant figures. So how do I do that? Well, I basically look at my 5th significant figure and I round it accordingly, and then I get rid of everything after that. So I look at my 5th significant figure. This is my first one, second, third, fourth, fifth. So here's my 5th significant figure. I look at the next one and I check, do I have to round it? The next number is 5, which means I do have to round it. So this 5 is no longer a 5 anymore. It will round up to a 6. So now that this is rounded up to a 6, I can get rid of everything else because I'm only rounding it to 5 significant figures. So my answer then is going to be 1.6736 times 10 to the negative 24, and that is to 5 significant figures. Now let's go through question 3. Write the mass to 3 significant figures. So it's the exact same thing as question 2, except this time I look at my first 3 significant figures. So 1, 2, 3, and then I check, do I need to round off my 3rd significant figure up or down? I look at it, the next number is a 3. That means I don't need to round up. I can actually just keep it as a 7. So my answer would just be 1.67 times 10 to the negative 24, and that is to 3 significant figures. Now let's look at question 4. Let's write the mass to one significant figure. So once again, we look at my first significant figure, which is 1. And now I look at my second significant figure, which is 6. So does that mean I have to round up or down? Well, the 6 indicates I'd have to round up. So this 1 now is actually going to be a 2. And I get 2 times 10 to the negative 24 kilos in this case, I'd assume. And that's to one significant figure. Notice how if I wrote 2.00, that's wrong, okay? That would be 3 significant figures. And that's why it's very important that you don't make silly mistakes like that. Just because it might look like the same, but this actually indicates a more accurate measurement, okay? This one over here is to 3 significant figures, whereas this one's only to 1 significant figure. So just follow the rule, look at the last significant figure, round up or down, and then get rid of everything after it. That's the way we do it. So now let's move on to the next slide. And it's deciding the amount of significant figures. If we are not given scientific notation, how can we decide how many significant figures a particular measurement has? An easy method to do this is obviously to just write it in scientific notation and then decide. So how do we do that? Well, in this case, we just write it as 2.3 times 10 to the power of 1, 2, 3, 4. So it'll be to the power 4. Now, if you're unfamiliar of how to change stuff from numbers to to scientific notation, please refer to our previous video on that. Now, if you look at this, well, clearly there's only going to be 2 significant figures. Now, there is a bit of a common misconception here, though. This is not necessarily only 2 significant figures. This can be 2 significant figures all the way to 5 significant figures. And really, this question is slightly wrong in how it's phrased. What it should say is it should say to the nearest 1, to the nearest tens, to the nearest hundreds, or to the nearest thousands. Why does that matter? Because if it's to the nearest 10, that means we don't care about this last decimal point, and it's actually 4 significant figures. If it's to the nearest 100, then we don't care about both of these, and it's actually only 3 significant figures. If it's to the nearest 1,000, then we don't care about this, and it's still just 2 significant figures. What if it was to the nearest 1? Well, if it was to the nearest 1, we actually care about every single number here, because all of these are specific to our measurement. And I know that's a bit confusing, but just remember that there's actually a range of significant figures unless they specifically tell you what the measurement is, okay? So this first example is very tricky, and I think just understanding that the answer is actually anywhere from 2 to 5 because they haven't specified, that's how to do the question 1. Thankfully, the rest of the questions 2 and 3 are much more simpler. With this one here, we can see we have 3 non-zero numbers, so we don't even need to change this to scientific notation. We already know that the answer is 3 significant figures. And finally, with this one over here, we can change this to scientific notation. So let's go ahead and do that. We have 8.302 times 10 to the power of negative 3. And this is going to be 4 significant figures because you can see we have a non-zero, and we have an in-between 0. And these are all significant as discussed in the last slide. So hopefully that makes sense. So significant figures rules. We're just going to be going over some of the things I discussed anyway, and we're just going to reiterate that. So rule number 1 is non-zero digits are always significant. Rule number 2, any zeros between 2 significant digits are significant. And what this is referring to is our in-between zeros. So in-between zeros. Leading zeros are not significant. Okay, that's what we talked about. And trailing zeros after a decimal point must be significant. Trailing zeros before a decimal point can be significant. And that's where we go back to this previous slide. The decimal point is here, right? These 3 zeros here, they're trailing zeros. They're before a decimal point. They could be significant. That's why we have a range of 2 to 5 significant figures. Hopefully that makes sense. So let's go through some easy examples. How many significant figures are in each number? Let's give multiple answers if possible. So pause the video, have a go at these 4, and then we're going to go through it. Okay. So with question one, you can see we have two non-zero digits. So those two are significant. And these are both zeros, which are before the decimal point, and so they could be significant. So at minimum, we have two significant figures, and at maximum, both of these zeros are going to be significant, which means it's going to be four significant figures. So 2, 3, or 4 significant figures would be the correct answer for question one, or 2 to 4. With question two, you can see we have non-zero, non-zero, non-zero. This is an in-between zero, so it is significant. And this is a trailing zero, but it is before the decimal point, so it could be significant. So that means we have four significant figures here with one that could be. So the answer would be 4 or 5 significant figures. Hopefully that makes sense. Now with question 3, we have 0.10000. Now if we look at this, we've got a 0, which is a leading 0, so it doesn't matter. And we have a non-zero, so this is significant. And we have 3 zeros, which are trailing, but they are after the decimal point. Okay, so those zeros after the decimal points means that they are significant. So there's actually only one answer to this one, and that is 4 significant figures. Let's move on to question 4. With question 4, we've got a leading 0, leading 0, leading 0, leading, 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 leading. So all the leading zeros, remember, are not significant. And then we've got 3 non-zeros, so they have to be significant. So once again, there's only one answer for this one, which is 3 significant figures as well. So hopefully that makes sense. So that brings us to the end of our significant figures video. For more practice questions, please refer to our homework video, which will be released shortly. And other than that, please make sure to check out all our other videos on the indices topic. Our next topic will be talking about simultaneous equations, so hope to catch you there. See you later.